important, hypochloric acid. Yeah? So then the water is getting enriched with hypochloric acid, and then it's going out into a freshwater tank. And imagine here is the freshwater tank. In the freshwater tank, we do have a sensor. This is a sensor, and the sensor is actually assembled into a tube, into a submersible probe, which is sealed, and then connected to a cable here to this plug. Yeah? And this is actually measuring the water quality every 10 seconds. Yeah? And if we detect a contamination in the water, the system is automatically, the computer is automatically reacting and giving more electricity, more current on the electrolysis cell, and the pump is automatically slowed down a little bit, so the water stays longer time in the electrolysis cell and gets enriched with hypochloric acid. Yeah? And then it's going to the freshwater tank, and as we measure every 10 seconds, we react, we see it very quickly, when the water is changing, and when the water is actually getting to a normal level again, so we reduce the electricity, the current on the electrolysis cell, and we speed up the pump. So then it's actually, going well, and the tank is getting full. So when the tank is full, it's still, the system stops when the tank is full. We have in the tank, we have also a level sensor. Yeah, it's connected here, and it's measuring the level of the tank actually. And when the tank is full, and suddenly, a rat is jumping into the freshwater tank, whatever, dying, you have a lot of bacteria. The system is detecting this. So what's happening? We cannot put more water into the system because otherwise it will flow over and something. So when the tank is full, we automatically circle. We have this valve here, and it's actually going around. And you see here there's a connection, and we connect this also to the bottom of the raw water tank. So the water in the not the raw water, the freshwater tank. So the water is circulating actually when it's good for schools or when you don't have consumption for a weekend or whatever. So it's automatically circulating. So the system is completely running on 24 volt DC. We have here an external power box. You see we have connected here 24 volt DC. Here is the AC-DC converter. We have here 220 volt. But we can also plug in here solar panels and at the bottom batteries. So actually the system works completely on solar and battery. And just if there is no sun, we can use the electricity from the grid to charge the batteries. So this system is fully self-adjusting itself. It's completely automatic. You put it somewhere in the borehole. You connect it to the water tanks, to the fresh water, to the raw water, switch it on, and it's producing guaranteed safe disinfected water. Okay. And it's never too much disinfectant, never too less, because we control every 10 seconds. And you see it here, when the water is really bad, for a rat, you might take the rat out first and empty the tank and then refill it. But the system then is shining red, it's giving a red signal, so the whole system is actually shining red. And when the water is good, the whole system is shining green. And when you have it in your shop, and the customers come and see the water is green, and you refill the bottles from the freshwater tank,
Yes.
And not from a hidden other tank somewhere around the corner, So you use this one. The customers get trust,
Yes.
and they see, how it's. I mean, you don't have running costs, you don't have operation costs, you don't need to save because there are no chemicals needed. Because the chemicals are actually for disinfecting are produced here inside, out of the minerals in the water, and you don't need electricity. You don't need nothing. You don't have any operation cost. 0.000. Yeah? So the only thing what you need to do sometimes is to use our maintenance tools, and the maintenance tools is a lemon and a toothbrush. Yeah? The toothbrush to clean the filters from time to time, to brush them. You can all open by hand, this is very easy to open. And the lemon juice, you can open the electrolysis cell here and here, disconnect it, take it out, and clean this plates here inside with lemon juice. Yeah, so you close it and you can also use vinegar. It's about the calcium that's sometimes stuck on this. That's the only thing you have to do. When it's getting white here, then you use the lemon, and when this going looks a little bit weird, then you use the toothbrush. That's all. Also, it's really developed for rural areas, for automatic areas. Yeah. So if you turn it on now, you see the screen. It shows not the right values. It shows green here now because we did not connect everything. So it shows some errors. But so that you just see the screen. And the valve is because we did not connect a level sensor. That's why. So this is how it looks like normally, not red. Normally it's green, the water drop. We don't know how much water is in the tank because no level sensor and no tank there. And we don't need energy because the system is not running. But this is how it looks like. Here you see the pump, the capacity of the pump in percentage. The pump is going 100%, 50%. Here you see the energy consumption of the electrolysis cell. Here you see whether the tank is filled up, or if there is a circle, the tank is actually